All right, the next ones, I can't quite get all on there, so I'm going to slide it up to here, and I'm just going to read off my paper. It says, a course in statistics is one of the most difficult at the local university. Because of this, for the past decade, the university has arranged for a teaching assistant to hold frequent discussion sessions as part of the course. Since the inception of the discussion sessions, 50% of the students enrolled in the course regularly attend the sessions. The other 50% did not. Students regularly attending the sessions have performed better than those not regularly attending. In particular, 65% of the students who regularly attended the sessions received a grade of B or higher, while only 35% of the students not regularly attending the sessions received a grade of B or higher. Let D denote the event that the randomly chosen student enrolled in the course attended the discussion sessions. The D with the bar over the top means they did not. Then B is that they received a grade of B or higher. The B with the bar over the top is that they did not. What we're basically going to do is fill out this little chart so that we have a way to rearrange what we're thinking. So, if 50% of our students did not attend the discussion sessions, how many did? The other 50%, right? I would take 1 minus that 0.5 that's down here, and so 50% did attend the discussion sessions. Same kind of thing here. These ones got a B and went to the discussion sessions. These ones did not get a B but went to the discussion sessions. We know that 35% did not get a B. What percent did get a B then? 0.65. 1 minus that 0.35, right? If 35% did not, then 65% did. So, if we're figuring out these things here with the and, we're going to multiply our two probabilities together. The probability of D was 0.5. The probability of getting a B was 0.65. So the probability of going to the discussion sessions and getting a B would be 0.5 times 0.65, which would be 0.3 what? 25? 25. The next row here, we want the probability of going to the discussions but not getting a B. So we said the probability of going to the discussions was 0.5, not getting a B was 0.35, just going across that one times that one, right? So 0.5 times 0.35 gives me 0.175. Okay? Now we're going to do the same thing on the bottom. Here, we did not go to the discussion sessions. The probability of getting a B was 35%. So the probability of not getting a B is going to be 65% again. That's the same numbers we had up there, right? 0.65. So, the probability of not going to the discussion sessions and getting a B, 50% times the 35%. Which we did right up here, was 1.75, right? The probability of not going to the discussion sessions and not getting a B means we're going to have the 0.5 times the 0.65. 0.5 times 0.65, we already did up at the top, 0.325. This one they happen just to use a lot of the same numbers. So, once we have our chart all completed, we want to find the probability that a randomly chosen student received a grade of B or higher. If they received a grade of B or higher, it means we don't have the bar above the B, right? Which means it could be the top one, They went to the discussion sessions and got a B. Or it could be this one. They did not go to the discussion sessions and still got a B. I'm just going to add those two probabilities together. So I'm going to take 0.325 plus 0.175, and then my answer is going to be 0.5. These are going to say do not round your responses, and so we don't have to worry about how many decimal places to show, 0.5. Okay? So, number 20. Recently, Hector ran for president for the local school board. Of those who voted in the election, 90% had a high school diploma, the other 10% did not. Hector got 70% of the votes of those with high school diplomas, while he only got 20% of the votes of those without high school diplomas. D is the event that the voter had a high school diploma. The D with the bar, they did not have a high school diploma. H means they voted for Hector. H with a bar means they did not vote for Hector. So again, we're going to fill out this chart, and then we'll answer the question based on what we get in our chart. Now I got to find my problem again. Where is Hector? That must be Hector there. And so, if I look here, 10% of my voters did not or do not have a high school diploma, right? What percent do have a high school diploma? .90, right? 1 minus that 0.1, 90% would have the high school diploma. So here, voted for Hector, had a high school diploma, did not vote for Hector with a high school diploma. We know 30% of these people did not vote for Hector, which means what percent did vote for Hector? 70. 1 minus 30%, 70%. So, filling out the rest of this top part of the chart, if I do have a diploma and voted for Hector, I'm going to take my 90% that had a diploma times my 70% that voted for Hector. So 0.9 times 0.7 gives me 0.63, right? On the second part of that, we want the people who had a high school diploma but did not vote for Hector. So had a diploma was 90%, did not vote for Hector was 30%. So 0.9 times 0.3 gives us 0.27. Continuing on, those without a high school diploma was down here. 20% of those without a high school diploma voted for Hector. What percent did not vote for Hector? 80%. 1 minus that 0.2 gives us 0.8 or 0.80, whichever way you want to write that. So, without a high school diploma and voting for Hector, 10% did not have a high school diploma, 20% voted for Hector, so we're going to take our 0.1 times our 0.2, and we would get 0.02. Do not have a high school diploma and do not vote for Hector. Not having a high school diploma, 0.1, times not voting for Hector, which is our 0.8. 0.1 times 0.8 gives us 0.08. Once we've got our table all filled out, we can go to our question. What is the probability that a randomly chosen voter did not vote for Hector? If they did not vote for Hector, we're looking for the ones with the bar over the H, right? So here they had a high school diploma but did not vote for Hector. Here they did not have a high school diploma and did not vote for Hector. I'm going to add those two things together. So if I take 0.27 plus 0.08, I would get 0.35. All right, number 21, pretty much the same thing. I'm just going to move it up to there. It says a sports psychologist performed a study of some visualization, yep, that word right there, techniques that she developed to improve athletic performance. She used amateur golfers and amateur tennis players as participants. In her study, 60% of the participants were golfers, the other 40% were tennis players. No participant was both. The visualization technique seemed quite helpful for both the golfers and the tennis players. 65% of the golfers reported a solid improvement, and 75% of the tennis players reported a solid improvement. So G is going to be the golfer, G with a bar, not a golfer, in other words, a tennis player. The I is that they had improvement, the I with the bar did not improve. Filling in our table. We know that 60% were golfers, so what percent were tennis players or not golfers? 40. 1 minus 0.6 gives us 0.4 down there on the bottom. Of those that are golfers, we want to find out what percent improved. We know that of those who were golfers, 35% did not improve. So if 35% did not improve, what percent did? 65. 1 minus 35 gives me 65. So, if I have my golfers and improved, to figure out the percent of my golfers that improved, I would do what times what?
0.6 times 0.65.
Exactly. 0.6 were golfers, 0.65 improved, so if I take my 0.6 times my 0.65, I get 0.39. The next line here, I want my percent who were golfers but did not improve. So what times what am I going to do?
0.6 times 0.2.
Exactly. 0.6 were golfers, 0.35 did not improve. So if I multiply those together, I get 0.21. Here we've already figured out 40% were not golfers, they're the tennis players. Here, these are how many improved of those people, how many did not improve. 25% did not improve, so what percent did improve? 75%. 1 minus that 25% would be 75%, right? So if I'm going to find the percent of the people who were not golfers but did improve, I would take what times what? The 0.4 were not golfers times the 0.75 that did improve. So 0.4 times 0.75 gives me 0.3. On the last line here, those that are not golfers and did not improve. So I am going to take 0.4 times 0.25. 0.4 were not golfers, 0.25 did not improve. I'm going to multiply that together and I get 0.1. Now that I have my table filled out, What is the probability that a randomly chosen participant reported a solid improvement after using the visualization techniques? So which one's improved? What numbers are we going to use? 0.39 and the 0.3, those both improved, right? So 0.39 plus 0.3 would give us 0.69 when I add those together, right? All right.